Okay, sorry. So yeah, I have a lot more slides than I have time, so I'm gonna probably cruise through a lot of these really fast. So stillsuper builds on top of a library called Lissinia. It's a server-side kind of GraphQL library that came out of Walmart Labs. So I'm gonna just take a quick look through that. And then the two libraries we're open sourcing is stillsuper, which is kind of connects a library to Datomic as an interface for that. And then CatchPocket is another library that will take a Datomic database, scan it, and then kind of produce a GraphQL schema that you can then run with stillsuper. Just as for our motivation for this, we have had a lot of the problems with REST that Dom described in the last talk there. We recently kind of had our big second client, kind of an iOS app for our existing website. And that was part of the motivation to explore GraphQL, was to try to see if we could find a way to avoid some of the problems that we'd seen with REST, with our kind of existing API structure. We're running on a Datomic backend. So that's kind of like the genesis of where these libraries get out of. Okay, so Lissinia is an open source library. It seems like the main one right now, as far as implementing the server side of GraphQL and Clojure. There's one or two more. But Lissinia is really well documented. It has a great tutorial, so if anyone is interested in kind of server side of GraphQL, I highly recommend like checking out their website, going through the tutorial. It does a good job of kind of like explaining to you sort of their philosophy and stuff. Yeah, again, Dom touched on this briefly, but there's basically, Lissinia is based on a series of resolvers. Resolvers are basically little functions that you write, and when you get a GraphQL query, Lissinia will sort of do a certain amount of execution for you, and at various points in the execution, it'll just call your functions. So the kind of two main things that you have to deal with are like, you have your kind of top level query that it's like, give me every user who's logged into the system. And then in the actual query, you might have like, for every user, find their name, find their image avatar, and for that image avatar, give me the width and the height and the URL, something like that. So these functions have the same signature, and it's all kind of recursive. But primarily, you're either getting data out of nowhere, or you have some existing data and you're sort of iterating or navigating into it. It's not super important to know this, but the next couple slides sort of demonstrate that. So yeah, this is kind of like your basic, super simple Lissinia schema. You define two objects as like a dumb music schema, right? So you have like an artist, you have an album, and then you have like a top level query that's like, give me an artist, given an artist ID. And if you notice here, these are it's kind of mostly metadata about the types of things that you are going to get back from a GraphQL query on this schema. But in here, there's this resolve key for some of these, and that's in the kind of Lissinia world. That's how you associate your own functions into the Lissinia execution. So when you actually call, when you get your query and you want to execute it, you sort of pass in a map that maps in like my album resolver to a specific function. So this is pretty familiar from Dom's thing, right? You'd have an artist query, you're passing in the ID from the front end, you're getting some stuff back. And so like again, this specific query with this previous slide winds up calling like two different resolvers. Right, and so again, this artist resolver at the top, you saw this in Dom's presentation as well. This is kind of what a resolver looks like. It takes 3 arguments, and it returns some data. So like, I'm gonna skip over that. And then at the bottom, you see this is kind of like the map where you tell it, like, this function can be associated with this specific resolver. Right, so that's just kind of like basic Listening stuff. It'll hopefully be a little more relevant when I get into the stillsuper bit. One brief little side note, the Datomic Entity API is kind of like what all this stuff is based on. That's an API that you can use in Datomic to sort of lazily evaluate attributes. Datomic is a very interesting data store. One thing it works as is kind of a graph database, and the Entity API is one way that you can sort of navigate the graph very easily and intuitively. One other thing I'll note here is that stillsuper and CachePocket are, well, stillsuper is based on the kind of, on this Entity API. As a result of that, it's not available in Datomic Cloud, which was recently released. There's probably various ways that you could implement GraphQL with Listenia on top of Datomic Cloud, but we haven't done it. And so currently, this will only work with Datomic, like on-premises installations. Okay, yeah. So basic idea of stillsuper. So basically, stillsuper is a way of sort of, it's a few different libraries together that you can take a Datomic connection, sort of stash it in the Listenia context, which is a little bit similar to like your request response model for a ring stack, where you can middleware sort of add stuff onto the request on the way down the stack, or adds it to the response on the way back up. Listenia has a similar notion called context. And we're basically stillsuper sort of like stashing a connection there. There's a bunch of resolvers that are built into stillsuper that sort of translate between the kind of GraphQL naming conventions, Datomic naming conventions, and then sort of puts it all on top of that Entity API I was talking about. And then a bunch of kind of resolvers that sort of handle the reference. References in Datomic are the ways that you sort of implement these kind of graph type features. A couple more things here. Serialization and deserialization of some Datomic types. This is not anything super special, but you can avoid writing it. So like one weird thing about GraphQL that's kind of unfortunate is that it defines ints as literal 32-bit ints. Datomic defines database IDs, which are unique identifiers for entities, as longs. And they are typically like, they are longs, like they won't fit in a 32-bit int, so you have to send them in as strings. So one feature of stillsuper is that there's like a little deserializer where you can send in a long as a string, and then in your resolver code, when you're trying to find the identity, like you'll get a long value. So it's not anything you can write, but it's just kind of, it's provided there for you. You don't have to think about it. Some other features, GraphQL has a notion of enums, and you can sort of represent those in stillsuper with a way to translate back and forth from like the GraphQL enum, which kind of comes across as a string, and kind of a keyword that you can look up in a Datomic database. There's some query resolvers, I'll get to those in a bit, and then Datomic back reference support. So every kind of, if you think of Datomic as a graph database, every edge link between two nodes has both sides, so you can get from either the thing being referred to back to the thing that refers to it, or you can get from one thing to another thing. Each one of those sides of those links could either be multiple entities or a single entity, and there's some kind of like fields to support that. This, unfortunately, I was not able to manage to get this thing to fit exactly onto one line, but you can sort of see where this is going to. So this is some kind of simple example. Again, this looks just like the Listenia. It looks very similar to the Listenia definition I showed at the first part of this, and the reason is that the way that stillsuper works is mostly takes an existing Listenia schema and kind of bolts some stuff on top of it. And we try to be pretty non-intrusive as far as like the Licinia API goes. For the most part, what we're doing is you give us some stuff, we add some stuff onto it, and then we just pass it into Licinia. So we're not trying to do anything super fancy there. So this resolver, if you'll see at the bottom, I swear there was a scroll bar in one version of these slides, but so your stillsuit ref, you're saying like I'm going to call the stillsuit resolver that's built into stillsuit, and like this is verified kind of GraphQL thing maps to the attribute value person is verified, and then you also have to tell it that what you're returning is a boolean. So this kind of will work if you have a person that's defined with these fields. If you have a resolver that returns a person entity from the entity API, then this kind of gives you a very simple way to expose all those attributes. Name and ID, there's also a built-in default resolver in stillsuit so that you can, if there's a person name attribute, then you can just kind of expose that just as easily. So that's kind of like basic operation. This thing here is like slightly more complex. This is using a ref again to navigate from one graph node to another. Again, thinking of Datomic as a GraphQL, as a graph database. So here, every person has one of our projects, and then we're telling it, the way that this is kind of structured in this hypothetical Datomic database is that a project has an attribute called members, which is a reference to multiple persons. And what this kind of does is set up a field in a person where you can list all the projects that they're a part of. And so like these stillsuit ref values at the end say like given a person entity, go to the project _ members attribute of it. And then that will give you multiple projects, and then you can also tell it for this set of, or for this list of projects sorted by the name of the project. And you can kind of do this, and there's a bunch more kind of twiddly little knobs you can fiddle with here. You can tell it that like this back reference only references a single entity, and then so you'll kind of get a single entity instead of a list of entities. There's a few other options here, but this is kind of like the basic idea of stillsuit. There's a big diagram about how it works. I'm not really going to dwell on that. These slides are all, if you go to the GitHub page, these slides are linked from there, so if you want more information, you can deal with that. You can get there. Again, some details that we don't really need to dwell on. Things that you have to write in stillsuit. I'm just going to skip over that. It's not that much. Here's a little more kind of, this might be yours, kind of like top level. I got my query and my variables from the web request, and now I want to actually run it and then return a response. So this is kind of like the basic things that you do with stillsuit. This options map is just a bunch of kind of configuration you get to stillsuit. You can see the connection there is an actual Datomic connection. Your resolvers is like the map that goes from resolver references to your own functions, like we sort of showed earlier. This main function, stillsuit decorate, just like takes a bunch of those options and then returns you a thing. It's actually a map with just like these two items in it, so it gives you a compiled Licinia schema, and it gives you an app context that is also something that Licinia needs. And then here at the bottom, we're just calling regular Licinia execute like you would with any other kind of Licinia base program. So like we're giving it the schema we got from stillsuit, query and variables that we get from the web, and then context, which we also get from stillsuit decorate. So again, we're trying to stick pretty close to the Licinia API and not do anything super fancy. All we're doing is kind of like adding stuff on top of an existing, more or less functional Licinia thing. I don't know why this header is so large, but mostly it's like the same thing, and it's just basically a shortcut. If you don't want to like extract those two things and then call the Simula execute yourself, we just have a little wrapper on it. So this is this is what our code that does this basically looks like. It's pretty straightforward. Okay, so that's pretty much the basic idea of stillsuper. These are some drawbacks. Stillsuper works great for our own data model, our own the Simula schema, our own stillsuper schema. Our own datomic schema. So it makes a lot of assumptions about data models. Some of this stuff is probably not going to be true for every datomic database. It's all very kind of like simple-minded. If you look at examples on the datomic website of like, here's a sample of how you might set up your data. Most of that stuff will work fine with this. If you have more complex stuff where you have attributes with different namespaces in a single entity, for example, like stillsuper probably will be very confused. Datomic cloud's not supported. I mentioned that. Pagination, so those ref attributes where you're getting every reference on one end of an edge node, and then you're sorting it by some value. That works fine for us. We don't have huge entities that have like 10,000 things at one set of a reference attribute. If you do have like large amounts of data in something that is on one side of an edge, then this approach might not work for you. We're thinking about ways to paginate stuff. Also, the schema files can get pretty verbose. Yeah, so that's a great segue to CatchPocket. CatchPocket is pretty much stillsuper for every attribute, every individual datomic attribute that you're exposing to GraphQL. You have to write one of those little Eden kind of summaries for it. The idea behind CatchPocket is that you give it the URL to your datomic database. It goes out and it kind of collects all the metadata about these are the kinds of attributes you have, these are the types, and it generates a large listening schema for you. Yeah, these are kind of like the basic bullet points. It will basically look for all your entities. It'll generate some Eden that defines a GraphQL schema for them. It does some nice things with it. You can blacklist, or you can whitelist or blacklist certain datomic entities so you don't have your hashed password accessible through your GraphQL interface. If anyone uses this dbdoc attribute, we do, but we don't update it very often. It'll kind of be there, and you can see it in the little graphical browsers. Another nice thing is if any entity that you have that has a unique attribute, you can get a query where you can give it that attribute. So like maybe a person ID, and it will give you back the entity that you got it. Again, this is not a difficult query to write, but this is something that kind of like automatically gets generated for you. You can configure a lot of things about like the actual namespaces. One thing that's not awesome about GraphQL is that the rules for what a field can be called don't include dashes and a lot of other characters that you're used to dealing with in Clojure. Anyway, so you can configure the way a lot of that stuff works. You can generate enums, like I was talking about earlier. It can actually like scan a database so that you say it will find every value in your database for a certain item if you tell it to, and then for each value that it finds, it will generate a little enum value for you, which can save you some time. Okay, so actually running CatchPocket, it's just a bunch of Clojure code. There's a bunch of dependencies in there that you probably don't want to run at runtime, so the way that we kind of think you should run this and the way that we run it is that you would kind of run it in some sort of build step where you make some changes to your database schema, you run this thing, it gives you a big Eden file, maybe you stick that in a jar or something. There's no reason you couldn't run it at runtime, but it has stuff like a color pretty printer for Eden that you don't necessarily want to have like hanging around in your web application space. Another pretty picture of this, you can look at it on the website. Okay, so in terms of like what you actually have to provide to CatchPocket, the main thing is that as far as the graph database capabilities of Datomic, it's a little unusual compared to like a SQL database you might set up, in that you can, there's nothing that says like everything that every artist slash person attribute, or I'm sorry, every artist slash album attribute actually has to point to an album entry. It's just a ref, so it can kind of point to any other entity in Datomic. This makes it very flexible because you could have kind of real heterogeneous collections of stuff if you want to. I think you would probably get confused. Anyways, but the one result of that is that when you have something that points to something else in your Datomic schema, you kind of have to tell CatchPocket, like, this thing is an artist and it points to an album. There's various things that we could do in the future about union types and kind of fancy stuff, but so the majority of your CatchPocket configuration is probably going to be like this one reference points from this thing to that thing, and then the way back points to this other type. This is kind of a pain in the ass, but it's a lot better than needing to enumerate every single attribute by hand. And you can also put the kind of metadata about what type things point to in the database itself. Right, I was mentioning before, Datomic links go two ways. Here's a very small sample, but this is kind of like what your config might look like. So in this schema, every secret agent has a country of origin, and then you just have to tell it that like the forward reference is from a secret agent to a country type. There's like a Licinia GraphQL type, and the back reference it can figure out that the back reference is going to secret agent, and you just have to tell it what the name is. Okay, that's basically it. We just launched these. They're both pretty alpha. Stillsuper, we've got a lot of use, but not on a large project. CatchPocket is a little more squirrely and fluid seeming right now. We have not really been focused on performance, and we want feedback. Yeah, please check them out. These are kind of future things in the future. We want to make good docs. Feel like Licinia, that project set the bar really high for documentation. We're looking at pagination, some other stuff here. We want to. That's basically it. You can go to github.com, Workframers. That's where this is. Also the project that Jorge is going to be talking about. Yeah. Thank you.